Find the power of k side subarrays. So we are given an array of integer nums of length n and a positive integer k. The power of an array is defined as its maximum element if all of its elements are consecutive and sorted in ascending order minus 1 otherwise. So what do we mean by power of an array? So let's say we have an array of size 5 and the elements are sorted in ascending order. So let's say we have elements 1, 2, 3, 4 and 5. Now power would be minus 1 if both of these conditions are not met. That first element should be consecutive. So do we have consecutive element in our array? Yes. And they should be sorted in ascending order. So our array is sorted in ascending order. Then power would be the maximum element. So what would be the power of this array? Maximum element, which is nothing but the last element, that is 5. If we would have array like this 1, 2, 4, 5. Now the elements here are sorted in ascending order, but the elements are not consecutive. Why? Because after 2 there is 4. So 2 and 4 are not consecutive. So that means in this case the power would be minus 1. Now you need to find the power of all subarrays of nums of size k. Okay. So what it is saying is that we would be given an array. Let's take this example. So we are given an array nums, and now we have to consider all subarrays of size k. So what is subarray? It's consecutive and ordered. So k equals to 3. That means what are all the possible subarrays? One is this, then 2, 3, 4, then 3, 4, 3, then 4, 3, 2, then 3, 2, 5. So now we need to return the power of these subarrays. So what would be the power? Let's see. For the first subarray, which is 1, 2, 3. So is it sorted? Yes. Are the elements consecutive? Yes. So its power would be the maximum element, which is 3. Now the next subarray would be 2, 3, 4. So are the elements consecutive? Yes. Are the elements sorted in ascending order? Yes. So the power would be 4. The next subarray is 3, 4, 3. So are the are the elements consecutive? Yes, because 3 is consecutive to 4, 4 is consecutive to 3. But are they sorted in ascending order? No. So power would be minus 1. Similarly for 4, 3, 2. Are the elements consecutive? Yes. Are the elements sorted in ascending order? No. So power would be minus 1. Now for 3 to 5, the elements are not even consecutive. So power would be minus 1. Okay. Now one thing to realize in this problem is that for power to not be minus 1, the elements would always be in something like this: a of I minus 1 equals to a of I, sorry, a of I would be equals to a of I minus 1 plus 1. That is, the current element should always be the previous element plus 1. So if that's the case, then the power would be just the last element. So for example, k equals to 3. If we consider these 3 elements, 2 is 1 plus 1 and 3 is also 2 plus 1. So 2 is 1 plus 1 and 3 is what? 2 plus 1. That is, 2 is the sum of previous element plus 1 and 3 is the sum of previous element plus 1. So in this case, the power would be just the last element of this subarray, which is 3. Okay, so how can we use this to find our subarray? So let's see. First, let's look at the constants. So constant is k would be greater than equals to 1 and less than equals to n. So if k equals to 1, then our subarray is just a single element. So in this case our answer would be nums only. So if k equals to 1, we would just return nums. But what if k not equals to 1? Then let's say 1 2 3 4 3 2 5. Now we need to satisfy this condition, that is a of I equals to a of I minus 1 plus 1, where a is this array, or you can call it nums. Okay, now why don't we just keep track of the range where these elements are, where this condition is satisfied? And how can we keep track of the range? We could have two pointers, L and R, which tell us the extremities of the range, that is between L and R this condition is satisfied. Okay, so so let me derive this condition here. A of I should be equals to a of I minus 1 plus 1. Okay, so let's initialize L and R to here, the starting element. Now and this would be our answer array. Okay, so k equals to 3. So we would first check whether this condition holds for the first three elements or not. So is this 2 is 1 plus 1? Yes. So then we would move our right pointer. Okay, then we move here. Is 3 2 plus 1? Yes. So that means we move our right pointer here. That means till this range our condition is satisfied. And now we have three elements. So what would be our answer? That is this current index I. So that is 3. Now we move again to this index. So what are we saying? Initially we initialize L and R to here, and now we are iterating over this array. So we would have another pointer, let's call I. So initially we are starting I from here. Why? Because we already handled k equals to 1 case. So now this k would be at least 2. So that means we would have at least 2 elements in the array. So we would start our I pointer from here. Now we would, for each iteration we would check whether previous condition holds or not. So for each iteration we would check whether this condition holds or not. So if a of I equals to a of I minus 1 plus 1, if this condition holds, then we would move our right pointer by 1. So since for this condition this holds, then we move our right pointer to here. Now and what if this condition fails? Then we will see. If this condition fails, then what can we do? Now after that we would check whether our current subarray size is greater than 3 or not. Sorry, greater than or equals to k or not, because we are concerned with subarray of size k. So currently it's not. And how can we check? We can simply check if r minus l plus 1. This would give us the size of the subarray. So we check whether this subarray is greater than or equals to k or not. And if okay, so currently it's not. So that means we haven't yet checked k elements. Now we would move on to next iteration. So now we would move to next iteration. Now is this condition holds? Yes, this condition holds. So we move again our right pointer here. Now we would have three elements, which is k. So now we have three elements, r minus l plus 1. It's greater than or equals to k. That means sorry. So since we are concerned with three elements, our first subarray would be at this index I, and this is at k minus 1. So when I equals to k minus 1, from that we would start pushing into answer. From this index we would start pushing into answer. Now we have to check whether we are in whether our subarray is in the range. So how can we check? So we want to check for k elements. So how can we check? So if this r minus l plus 1, if this is greater than or equals to k, that means our subarray, so let's say this is l and this is r, and our subarray is like this. So that means our subarray lies in the range where this condition is satisfied. So in that case, we just push the current element, which is nums of I or nums of R, which in our case is 3. Okay, cool. So if this condition is true, then that means we'd push in answer the current element, which is nums of I. And if this condition is not true, then we would just push -1. Okay, now only this condition is left. What we would do if this condition doesn't hold? Okay, so let's see. Now in next iteration we move I here. Now this is again true, so we move our right pointer to here. Now since this condition is satisfied, that means we would push 4. Now we again move the I pointer here. Now this condition is not satisfied, so in this case what we would do? We would move both our right and left pointer to here. Why? Because now in all the subarray where we're considering these pairs, the power would always be -1. So that's why we are shifting this both right and left pointer to the current index. Now in this case, since this condition would not be satisfied, that is our subarray the subarray whose power is where this element is satisfied is not of size k. So that means we just push -2. And now we'll move again our I pointer to here. And then we would check whether this condition holds or not. No, then we would again move our right and left pointers to this index. And again similarly we would check for this. So let's look at the code. Okay. Now, so initially we initialize L and R to 0. And if k equals 1, then we would just return the nums array. We are declaring vector of answer so that we can return it. Now we are iterating over the array and we are checking if this condition is true or not. That is a of I equals to a of I minus 1 plus 1. If this holds true, then we would move the right pointer. Otherwise we would set both the left and the right pointer to the current index. And if this condition holds true, that means so basically what are we trying to do here is this condition is checking whether we have surpassed the first subarray. So basically let's say if k equals to 4. Now we are checking from here. We are checking these conditions from here, but our first subarray would come from here, that is 0 1 2 3. So if k equals to 4, then first subarray we would get the first subarray at I equals to 3, that is k minus 1. So when I is greater than or equals to k minus 1, then only we would start pushing into the answer. So if this condition holds true, that means our subarray lies in the range where this condition is satisfied. So in this case our current element would be the answer, because that would be the maximum element. So we would push nums of I, otherwise we would push -1. And that's all for this problem. Thank you.